Today, our group will be discussing self-consolidating concrete. And up first, to introduce the product, is Cole Landry. Concrete is one of the most common materials used in the construction industry today. Concrete is used for everything from parking lots, building foundations, walls, and ceilings. One common component of normal concrete is that a vibrator is needed to get the concrete into small corners and nooks that it needs to flow in. One easy solution to this problem is by the use of self-consolidating concrete. Self-consolidating concrete is a new class of high-performance concrete that is able to flow and consolidate under its own weight. Self-consolidating concrete is a highly flowable, non-segregating concrete that can spread into place, fill formwork, and encapsulate the reinforcement without the need of mechanical consolidation. This allows concrete to flow into corners and hard-to-reach crevices without the need for a vibrator to get it there. It also self-levels itself over large horizontal distances. Early in the development of self-consolidating concrete, numerous additives were put into the concrete to allow it to flow while maintaining stability. Now, there's a powder that contains all the cementations and fillers needed. The fillers are very fine to reduce the water to cement ratio. Free water will increase the concentration of the admixture, which could ruin the self-consolidating properties. The elements that allow self-consolidating concrete to flow so smoothly are surprisingly simple. According to the National Ready-Mix Concrete Association, an association that keeps up with the most recent advances in the ready-mix industry, self-consolidating concrete is made up of a high-range water reducer admixture, and not by adding more water to the mix, just like normal concrete. The more water that is added to the concrete, the higher the risk of reducing the strength and performance.
The biggest advantage of self-consolidating concrete is its superior flow ability. A professional in the industry said, "The concrete passes easily through armatures and obstacles." Also, according to Kamal Henry, a doctor of engineering, writes, "It completely fills formwork even in forms with dense reinforcement." Even when the concrete is poured into areas of dense reinforcement, there is no need for additional compaction or vibration. Since there is no need for additional consolidation, this concrete can cut down on overall labor costs. NRMCA states that self-consolidated concrete can be placed at a faster rate than traditional concrete. This also cuts down on labor costs. The flowability of this concrete allows it to be pumped through a pump truck much easier than traditional concrete, since it flows so much easier. Self-consolidating concrete also has some downfalls. One big downfall is that this concrete costs much more than traditional concrete. According to NRMCA, self-consolidating concrete can cost up to 25% more than traditional concrete. It also takes more time to test than traditional concrete. The major downfall with taking more time is that the concrete is time sensitive. Lastly, this concrete is new to construction. This creates a few trust issues with using this concrete. Since the contractors are responsible if something goes wrong, they are hesitant to use untested or unfamiliar materials.
And I will be talking about our interview with Taylor Harrell at Cajun Industries. As you know, Cajun Industries is a local company that specializes in heavy civil, um, mechanical, deep foundation, and even marine construction. So they're very familiar with the different uses of concrete, especially self-consolidating concrete. We asked Taylor what his position was with Cajun Industries. He said he is the estimating coordinator, and so of course we asked, what history he has with using self-consolidated concrete. Um, he said at Cajun they use a company named Design Precast for um, like catch basin materials. Design Precast uses self-consolidating concrete on all of their precast items. So we asked them, what do you use it for? They use self-consolidating concrete for columns exceeding 15 feet in length. The reason for that is that the additive in self-consolidating concrete stops it from segregating from the aggregate in the sand. This type of concrete, since it doesn't need vibration to get into the corners, which prevents honeycombs as well as the loss of vibrators getting stuck in the rebar. So we asked Taylor, if any, what are some projects that self-consolidating concrete has been used for? He said most recently, the Tiger Stadium was supposed to have used that type of concrete. The plans and specs called for self-consolidating concrete, but they value engineered it out of the project. Instead, poured all of the columns as standard concrete mixed design. The reason for this is that it costs approximately $30 more per cubic yard versus the standard concrete, and it just saved the company a lot of money. So we asked Taylor, are there any specified tests when using the self-consolidated concrete as opposed to a standard concrete mix? He said, yeah, there are 3 different tests to be done. The first test is called a spread test. Second test is the L-shaped test box test, or the U-shaped test box test. And the final test is called the slump float test, which Hamlin will be talking about the different tests used for self-consolidating concrete. So we asked Taylor, what is the difference with placing self-consolidating concrete versus a standard mix? Taylor responded saying that for the first part, self-consolidated concrete is placed the exact same as standard mix. The only difference is that it doesn't need a vibrator to get in a position. So, it self-expands into the cracks and crevices and corners. And not only is the vibration not necessary, but it can cause damaging to the concrete by causing segregation. And so last but not least, we asked him, how's it finished? He said, as far as finishing the concrete versus a standard mix, it's done the same way. You would think that because it's self-leveling and it has that special additive in it that the concrete would not need to be finished. But self-consolidating concrete does still indeed need to be finished, but it requires less floating.
I'm Hamlin Miller, and I will be talking to you about the slump test. Traditional concrete testing is done with what is called a slump test. A slump test is a metal cone in the shape, that metal cone called the Abrams cone. The cone is about 1 foot tall with an opening at the top and the bottom. The top opening is about 4 inches in diameter, and the bottom is about 8 inches in diameter. The cone is then filled to the top with concrete. After being packed into place, the cone is then removed and gravity takes over. Once the cone is removed, the concrete will then slump or shrink in height. This slump is measured from the original height in millimeters, and that's your slump. The maximum acceptable slump for high workability mix is between 90 and 100 millimeters. The lowest acceptable slump height for a very dry mix is between 0 and 25 millimeters. The slump is completely collused and the mix is too wet and cannot be poured at all due to strength issues. The interesting part about the self-consolidating concrete is that the traditional and highly trusted system to estimate concrete strength cannot be used to test any self-consolidating concrete. The reason for this is because of what the concrete was originally designed to do, self-consolidate. So when the mix is poured into the Abrams cone, it just flattens itself, appearing as if the concrete is too wet and doesn't have any strength. Although according to the traditional slump test, this concrete would be too wet, it would actually still be strong enough to be used. This is why another type of test was developed to test self-consolidating concrete strength. The newly developed test used is what's called the spread test. According to the NRMCA, the spread test is done using the Abrams cone used for traditional concrete. The cone is filled to the top, is the same as the traditional concrete. The difference is that when the Abrams cone is removed, the spread of the concrete is actually what's measured instead of the slump of the concrete. The NRMCA states that the concrete should only spread between 18 and 32 inches in diameter after the Abrams cone is removed. Any more than 32 inches and the concrete begins to lose strength. and any less than 18 inches, and the concrete won't flow as easily as it's supposed to. Also used during the spread test is the concrete's resistance to segregation, also known as a visual stability inspection. This test is performed by observing the amount of water that rises to the top during the spread test. If too much water rises to the top, then the concrete cannot be used due to strength issues.
And I'm going to finish up this. So we believe that self-consolidating concrete is the future for concrete, and that in the long run, the benefits do outweigh the negatives. Plus, once more suppliers move towards using it towards the future, eventually, and more people tend to use it, the kinks will be worked out with the small issues that some people may have with it, with the inexperience of using the product in the long run. Eventually, self-consolidating concrete could be a big heavy hitter in the industry. It is quite expensive, but in some applications where you need self-consolidating concrete, it could definitely be very beneficial for the project. Self-consolidating concrete is beneficial to the industry because it will create a safer work area with increasing the speed and productivity and the cost efficiency of the product. When you put all those things together, safety is number one in construction. So if you can increase the speed and productivity of something without decreasing the speed or the safety in which it can be done, then that's always a benefit when you're looking at time is money. So if you can save time is money, then this is a good product for you to use. And it's not beneficial in all applications. As one of our interviewers said, they actually VE'd it out during the build of Tiger Stadium. And they did that because it wasn't cost effective. It's too expensive. And over time, that price may come down and it will eventually become a much more readily used product. But overall, we think that this being a new product, that eventually this may take off and could end up being a very heavy hitter in the industry. Thank you. You have a great night.
This thing on? Oh, hey. Today we will...
That's fine. He can edit that, though.
I looked at myself.
He can edit that. No, just keep going. You can just go with the paper now. Just go with the paper now. You can cut that out.
All right.
You did it good. You did
That's
real good.
I tried to, dude. Because the problem is I looked at my paper and then I looked down at myself and I was going to say today because I went like this and I looked at myself like that.
Oh, hey.
Oh, hey.
All right, good. I will cut that out.
All right.
Hi, I'm Hamlin Miller, and I will be talking to you about the testing of self-consolidating concrete. Hi, I'm Hamlin Miller, and I will be talking to you about the
Now there's a powder that contains all the cementations. Is that
Really?
what you said? Cementation?
Shit. You're going to go with shit. That would have worked if you wouldn't have said shit.
All right, hold on.
It's cementatious.
Cementation. It's cementations.
Whatever.
Is that it?
That's fine.
Cementations.
Yes.
All right. Let me just
Start
restart
the whole
this.
fucking paragraph over now.
All right. early in the development of self-consolidating concrete, numerous additives were put into the concrete.
Industries is a local company that specializes in heavy civil, mechanical, deep foundations, and marine construction. So they do have a lot